Give you a couple more seconds. Sorry, that was probably obnoxious for you people on Teams. All right. It's just so little here that it's like throwing me off. All right. So determine if the following is a function. This one's going to be not a function because it does not pass the vertical line test because of this little section in there. Increasing, decreasing, constant. I'll go through that also slightly quick because we did warm-ups like that the other day. The slope I'll slow down slightly. So here, decreasing, constant. So we're essentially breaking it up. Excuse you, screen. Here, here, and here. So that first section at the very end is from negative infinity to -2. Remember, you're always using the x values, not the y values. And that's going to be decreasing. So from negative infinity to -2, we're decreasing. That next piece from -2 to 0 is going up, so increasing, so -2 to 0. Constant in that next piece from 0 to 3. And then that last piece from 3 onwards, so from 3 to infinity, is decreasing. So brain 3 to infinity. Again, the other day I kind of said that if you do brackets, that's perfectly fine. Brackets versus parentheses, that's where everyone is. Lord, did you all come from the same place or something? What happened? Hello. Oh my God. Were you in the wrong room? What happened?
We're all just chilling outside.
Why? Okay, this makes more sense. Anyway, moving on. So again, it was brackets versus parentheses. Your choice, except for the infinities, must always have parentheses. The actual numbers, you can use whatever floats your boat. Now I should sit down again because people are over there. And then this last piece was kind of our new thing that we talked about last time. Find the slope between 2 points. So again, it doesn't matter which point you use as, your x1, y1, x2, y2. I always, personal preference, put the larger y value first. So I would do 8 minus 2 over 0 minus 5, which would give us the arithmetic 6 over -5. Or if you did it the other way, 2 minus 8 over 5 minus 0 gets you the same thing, except the negative would have been on the 6. And then part B, again, I personal preference like to put the larger y value first. So 17 minus 5 over 2 minus -4. 17 minus 5 is 12. At least that's what I wanted to be. And then 2 minus -4 is the same as adding 4, so that's going to be 6. So 12 divided by 6 is 2. Questions, concerns? Or if you had done it the other way, 5 minus 17 over 4, -4 minus 2, you would have gotten -12 over -6, which still gives you +2. Negative divided by a negative is positive. All right, so if you're comfortable with those ideas, you should be fine on your quiz. I'm at the end of class. So if you have questions, let me know. Yeah, what up?
Okay, for A, for 3.
Mm-hmm.
I think I did like the 2 minus 8, which gives me like -6.
Mm-hmm.
And 5 minus 0, which I get 5.
Yeah, so you got -6 over +5, right?
Yeah.
That's the exact same thing as 6 over -5. It's the exact same number. More questions? No, I did start recording, right? Yes, I did. Okay, cool. Of course, people on Teams, if you have a question, pop it in chat. The setup, the screen isn't well, the one screen isn't working, so I might not see it right away. But I will be checking that every once in a while and I'm just gonna leave it up. That's probably gonna be easier for my life. Can I make it smaller? No, I can't. Oh well. So now, why is this weird? Oh, because I made it full screen. That's why it's weird. Unfull screen. So now we've got to go to our notes. So we started 1.2. Well, I gotta do it right. Gotta actually do it correctly. Boink. There we go. And I want to redo my words for this example one that we ended on because I feel like I explained it really poorly. So I'm going to do that again. If you understood it the first time, sorry, not sorry. Just listen to it again. So to remind us, we were having to interpret two different things. So interpreting the y-intercept was a bit more familiar. This mask is looser, but it's easier for me to talk in, but it's falling down. Okay, there we go. So we did that over here, but then we wanted to interpret the slope, which was the new piece of it. You know what? I don't like this here. I'm going to make it go away. So what I was trying to get across last time that wasn't getting across very well, there's two ways you can do this. So there's always two choices you can take if you want to interpret a slope. The first way is that I'm going to call it the rate way. And essentially what it's going to do is it's going to go back to the idea of the definition of slope. So the definition of slope, to remind us, was the rate at which the y values change with respect to x. So I'm going to make a little side note up here. Sorry, things are popping up on my screen. So it's a change in y over change in x, right? So that's going to give us that the units of the slope. If you talk about the units of the slope, it's going to be units of y over units of x. So I know I ran out of space a little bit over there. But that's essentially going to be the way that we're going to find the units of the slope, and that's going to be helpful for the rate interpretation, is we're going to need the units of the actual slope. So if I wanted to say it that way, how that's going to go is you're essentially just going to take the context of the y value. So here the context of the y value is the time to run the world record time to run the mile. So you'd start your sentence off by essentially reminding people what the y value context is. So the world record time to run a mile. And then you're going to say whether it's increasing or decreasing, and that's going to depend on the sign of your slope. Here we have a negative slope, so we're going to say decreasing. So the world record time to run a mile is decreasing. And I call this the rate way because then you say at a rate of 0.4. Now I just take 0.4 instead of negative 0.4 because the word decreasing is taking care of the negative for me. And now I need the slope of the units of the slope, which actually I wrote here the other day. So it will be, it will be decreasing at a rate of 0.4 seconds per year. So that's the one way you can do it. And then the other way you can do it is the one I think I actually really butchered trying to explain. I'm going to call that the step way. And the step way, what that is going to get us is essentially we're looking at what the slope actually means. And if you think about what the slope actually means in terms of like a straight line and what it's trying to tell you, it's essentially telling you, I have to erase this 260. If you move over, how much you move down, right? So when you first, I didn't present it like this here, but you might have seen slope before in your life where that's usually how it's originally presented. It's rise over run, and they always draw the little triangles, right? Now, for the case of interpreting in this way, we're always going to take the jump to the right to be 1. And the reason we're going to do that is that allows us to make all of these little jumps down to be equal to whatever the heck the slope is, okay? So technically, if your slope was like 2/3, that could tell you over 3 down 2. We're always just going to take it to be over 1 up or down, however many your slope tells you, right? So what we're going to do in this way is this is essentially what we're looking at. We're going to say that we're going to increase the t value by 1. We're going to take a step over to the right, and then the y values are going to decrease because we're going down by 0.4. So that's how the interpretation for this piece is going to go. We go over 1, down the slope, or up the slope, depending on the sign of the slope. So how we're going to do that is I also need to take into consideration kind of where the t values are going to be starting here. And since it's years since 1900, I'm going to bring that in to play as well. I kind of have to have a starting point. So I'm going to say for each additional year after 1900, so that's telling me if I go over 1 for each additional whatever context, the world record time, I should be specific, the world record time to run a mile will decrease by 0.4. I'm running out of space, so I'm going to abbreviate seconds. Now, in this case, you only use seconds because of the fact that we're taking the slope we're interpreting the slope in this manner. We're saying if we increase the t by 1, that tells us to go down that many in the y direction. So it's no longer the slope units, it's just the y value units because we're taking it to be over 1 down slope or up slope, depending on if it's positive. Does that make sense? So you can always choose between whichever one makes you happier. So I think that was hopefully a better explanation than I did the other day. And the reason I also want to stress this so much is because while it's going to disappear from our lives for a little bit, it's going to come back up in a couple more chapters. So I at least want us to at least be semi-used to seeing it. Okay, so onward. So now we're going to go into actually how to write the linear equation given 2 points. One thing I like to try to do, I try to remember to do, is to give you these processes along the way. When it comes to studying mathematics, especially if you're not a math person, quote unquote, you're not good at math. Everyone's good at math if you just practice it enough. The thing I always suggest studying more than doing problems until you're blue in the face, I do suggest doing practice problems. I'm not suggesting you do practice problems. But the thing I think it's better to study is these processes. Because you can do problems till you're blue in the face, but for some reason there's this phenomenon where I can write a question that you're just like, you read it and you're like, I know I did ones like these, but I forget. Whereas if you're specifically studying, okay, well, I'm going to memorize the process to write a linear equation, then you're like, okay, this is a question that I need to write an equation of a line. Okay, well, then I need to find the slope, and then I need to do that. If you remember the steps in your head, no matter what question I throw your way, you're going to be able to slow down and walk yourself through it. Okay, so that's kind of why I try to add these processes in every once in a while, because I think they help. Maybe they don't. Maybe I'm just crazy. But anyway, here we go. So to find the equation of a linear line given 2 points, first thing you're going to do is you're going to find the slope between those 2 points. So find the slope. You're going to take this slope and you're going to choose 1 point out of the 2 that you're given to use in either slope-intercept form or point-slope form. So remember, there were the 2 different types of forms, whichever one floats your boat. And then whatever your third step is depends on which form you want to use. So if you're going to use slope-intercept form, you're going to plug in the values for y, m, and x. So m is the slope and the x and y is the point that you chose. And then you're going to solve for the remaining value of b. Now, for some reason, lots of people think that they're done at that point, but then you have to remember to actually write the answer. So then you use the m value and the b value you just found to actually write the equation as y equals mx plus b. For some reason, lots of people always forget to actually write the answer. If you use point slope form, you're going to plug in the values for the slope m, x naught, and y naught. And so whatever x naught and y naught is going to be the point that you use. It's just that that's the notation I use in point slope form, so that's what I'm going to use here. You will usually then want to solve for y, and some people go a step farther and actually solve it so that it looks like y equals mx plus b. I'm not a big stickler for one over the other. Wiley might be. I don't remember. But for me personally, if I just say write the equation of a line, if you just do the generic point slope form and you don't solve for y or anything like that, I still count it as correct because it's still technically the correct equation of a line. Okay. I think most people are usually used to the y equals mx plus b way. The first example I'll do both ways, and then I'll kind of get a feel for which one y'all prefer. And if it's kind of down the middle, then I'll just jump back and forth between the two. But anyway, so that's how we're going to be able to write the equations of these lines. So let's see an example. So the solid waste generated each year in the cities in the U.S. is increasing. The solid waste is generated in millions of tons. The solid, but was, yeah, oh, that's not a number. What is this supposed to be? I never fixed it. This number here is supposed to be 2 point, no, it's not. 238.3. So the only point is supposed to be the 0.3 at the end. My bad. So it was 238.3 in 2000 and 251.3 in 2006. Assuming that the amount of solid waste generated by U.S. cities is a linear function, find a formula for this function by finding the equation of the line through these 2 points. Use the formula to predict the amount of solid waste in the year generated 2020. Okay. First thing is I'm going to use the usual, what's the word I want, convention of whenever we're working with time, I'm going to have time be in years since something. So we're going to let t be in years since, and since the first data point is in 2000, I'm going to say years since 2000. And that's just going to allow us to plug in much smaller numbers than 2000 and 2006 because those are tedious. So let me figure out what the 2 points I'm actually working with are. So it says that assuming the amount of solid waste is a linear function of time. Linear function of time. Since it says of time, let me phrase it like this. Waste as a function of time. If I take out some of the wordiness in that, that's essentially what it's saying, right? The waste is a function of time. And remember that that's essentially going to write itself out for us. So say I use the variable w for our waste here. So I'm going to have waste is a function of time. All that to say, I wanted to figure out which ones were going to be my quote-unquote x values and which are going to be my quote-unquote y values. So here we're going to have t being our x's and our w's being our y's. So let me then figure out what points I'm working with here. Well, if I let t be in years since 2000, then the 2 points that I'm given is, so 2000 is going to turn into 0 then, and the waste was 238.3. And then the second point was in 2006, so my time is going to be 6 and 251.3. So at this point, I've just gotten to the point where I can start writing the equation of a line because I needed to figure out what my 2 points were first and which order they went in. So now I can go about finding the equation of the line. So my first step is always find the slope. Personal preference, I always like putting the larger y value first. So I would do 251.3 minus 238.3 divided by, but then if I do the 251 first, the 6 must come first. 6 minus 0. Now this one does turn out to be a fraction that has to kind of stay a fraction, so it is a little gross, but it's all right. This is going to reduce to 13/6. As long as I did it right when I typed it in my calculator. So that's going to be our slope. I'm going to leave it as a fraction. If you changed it into a decimal, I wouldn't be mad at you. But I'm also going to be slightly strategic in this next step to make my life slightly easier, because now at this point it would tell me that I need to pick a point. Now, technically, you can shortcut this one, but I'm not going to shortcut it so that we go through the full process, because you can't always shortcut it. I'll talk about how you could shortcut it in a second. But notice that I have a 6 in the denominator, but I also have a 6 here, and I'm going to be multiplying the slope by the x value. So I'm going to go ahead and use that point in my y equals mx plus b to solve for b, because then it'll cancel out super nicely, and yay. So my next step would be to, so I'm doing the slope intercept way first, okay? So if I wanted to do the slope intercept, so that's y equals mx plus b. But here we have w equals mt plus b, just to be clear. So I'm going to pick this point right here as the point that I'm going to pick. So I'm going to plug in all the values that I know. So I have 251.3 equals my m value of 13 over 6, my t value of 6. Don't know what b is. If you multiply 13 over 6 by 6, the 6's cancel. And you're just left with 13. Subtract 13 from both sides. You get 238.3 is your b value. And again, this is where people, for some reason, stop and forget that you're not technically done. You haven't actually written the equation of the line. But now that you have the b value, you can write your y equals mx plus b with the correct variables for the problem. So we have w equals 13 over 6 t plus 238.3. So this would be our equation of our line. Now, how could you have cheat sheeted that? And I also want to do the point slope form in a second, just in case anyone likes that way and wants to see it really quick. Technically, we already have our y-intercept, because remember, the b value is the y-intercept. And remember that the y-intercept is when x is 0, whatever your x variable is. Technically, we already know what value that is because we're given the point where xt is 0. So you could have just said, well, the y-intercept is 238.3 and been done with your life. You can cheat sheet that way if that's possible. That's not always possible, so I wanted to go through the full way. Really super quick, if you wanted to do the point slope form, say I chose the same point because I don't want to use 0 and cop out in any way. So I'm going to use w minus 251.3 equals my slope value of 13 over 6, t minus 6. You could leave it like that. You could distribute it out and swing the 251.3 over if you really wanted to, whatever floats your boat. The only thing, be careful in Wiley. I think Wiley usually wants y equals mx plus b form. You can get from here to there. It just takes a little bit of work. But whatever floats, if it's a question written by me on a quiz or exam, I don't care. Whatever floats your boat. Savvy? But then we had another piece of this that says use the formula to predict the amount of solid waste generated in the year 2020. Good old 2020. So what value do I want to plug in? 20. Because remember, it's years since 2000. So I want to plug in 20. So I have 13 over 6 times 20 plus 238.3. I trust and believe we could type that into a calculator. So I'm going to just jump straight to the answer. This is approximately 281.6. So I did change it to a decimal along the way. If you leave it as a fraction, I don't know what the fraction would be. I don't have a calculator on me. But if you, I don't mind fraction versus decimal. I also don't care about that either. And we should, though, state the units on this. So this is a waste value. So the waste value is in millions of tons. So solid waste generated in millions of tons. So we should say that this is 281.6 million Tons. Savvy? Okay, we end at 05, so that means I want to stop talking at 3:50. All right. So we're going to be able to recognize if a data set is linear. So that's the next thing we're going to look at. I'm going to give you a data set. We're going to have to figure out whether or not it's linear. We can figure out if it's linear if the difference in y values is constant for equal differences of x. Equal differences of x. Okay. So how are we going to do that? So say I have these data sets and I want to determine if they're linear or not. You could do literally every pairing and literally finding the slope between every two sets of points. I like to do it this little, it's not really a cheat sheet way because it's correct, but it's not taking that much time. I like to do these little loopy loops. And I just like to look at how much it goes from one to the next. So from 0 to 1, I increased by 1. From 1 to 2, I increased by 1. From 2 to 3, I increased by 1. From 25 to 30, I increased by 5, and then by 5, and then by 5. Okay? So I don't necessarily have to take each and every pair and find the slopes between them, but if you wanted to pull off all of these points and find the slope between them and see if they match, you can do that as well. Okay? But here, I just think this is a nice, simple way to make sure it works. Now, this one, it's kind of easy to see because they're all 5s and 1s. That's not always going to happen, and you could still have it be linear even if they're not all the same number, and I'll get to that in a second. Because the thing you want to make sure is constant is the ratio of the change in y to the change in x. So you always want to make sure that the change in y over change in x, so the first change in y over change in x was 5 over 1. But then that's equal to 5 over 1, which is equal to 5 over 1, which is 5, right? So in each case, the ratio of the change in y over change in x is constant, so this is linear. Does that make sense? Whereas this next one, if I look at my little loop-de-loops, I increased by 2, by 1, and by 1. So don't just stop there and say the numbers aren't the same, because that's not the point. And then down here, I increased by 10, increased by 5, increased by 5. So again, now we want to look at the ratio of the change in y to change in x. So the first change in y over change in x is 10 over 2, which is equal to 5. The last two are 5 over 1, which is equal to 5. 5 is equal to 5, so this is linear. So it's not just that you're looking for the numbers in the little loopy loops to be the same. You want the ratio of the change in y to change in x to be the same. Okay? So, and I got to remember that you don't have this nicely in front of your face, so you might need to write more to keep up with me, but everyone seems to be. All right, I'll take a drink of water really quick. Apparently fall out of my chair. This last one, so if we look at our little loops, we increase by 10, increase by 10, increase by 10, and oh Lord, decimals. We decrease by 0.4, decrease by 0.2. At that point, you could already stop because we've already found something that's not going to work, but let's just find the last one anyway. And then you reduce by 0.2. So here, just making it extra clear, we take our ratio. I didn't actually find out what those are, but I'm just going to write this because I think it's clear because the denominators are the same. Those ratios are not going to be the same, right? Because the denominators are the same, but the numerators aren't. So since the ratios aren't the same, this is not linear. And that's all you need for those. Kind of simple. Although I should avoid the word simple in case it's not simple for someone. I should shut up. I'm rambling. It's just spewing out of my mouth now. I'm good. Okay. So we're almost done this set of notes, and then we're on to 1-3. Yay! So the following data is linear. So super nice, we don't have to check it. We're just told that it's linear. Write an equation for P as a function of Q, and then a function of Q, and then a function for Q as a function of P. I don't know why my brain short-circuited when I read that. State the units for the slope in each case. So essentially it wants us to write two different equations, depending on which one we take to be our quote-unquote X and which one we take to be our quote-unquote Y. So I'm going to split this down the middle so I save myself enough space. And I'm going to give you all a couple seconds if you're writing down the table. So let me... So the first one I'm going to do is P as a function. Sorry, something's happening on my side that's not happening on your side. Stop. Stop. Go away. Lord, stop it. Thank you. P as a function of Q. So again, a couple days ago, I said that you want to be really familiar with this phrasing, and I meant it. So also the nice thing about the phrasing was that it essentially just writes itself out. So if P is a function of Q, we know that our P values are going to act as our Y's and our Q values are going to act as our X's. So it's kind of, the table is now kind of opposite to how you would kind of want it to be in your brain. So since I only need 2 points to write the equation of a line, let me take 2 data points off of that and just use those. So I'm going to use, I don't know, just these first 2. Those look nice enough for me. So let me write them down in terms of the format we're going to need for this. So our Q's are our X's, so we're going to have 100, 5, and 90, 10. So of course, the first step for writing the equation of a line is to find the slope. So I've got to find the slope. So personal preference, I always put the larger one first, larger Y value first, but then I got to be consistent. So 90 minus 100. That gives us 10. No. Sorry. I'm reading off my notes and they did it the other way first. So 10 minus 5 is 5. 90 minus 10 is negative 10, so that reduces to negative 1/2. So now I get to pick, actually I should have done this before. So we have y equals mx plus b, and we have the y minus y naught equals mx minus x naught. I know this isn't going to really help on teams, but if you're here in class, raise your hand if you prefer y equals mx plus b. Raise your hand if you prefer the other way. Handful, but not really. Okay. That means most of the time I'm going to go this way. If you ever want me to show you the other way, just yell at me. And of course, you can use it however you want. But since the large majority of people usually like the y equals mx plus b, for the large majority of questions, I'm going to use that. And I might jump to the other one just to, clarify how it would be. Or if one of the people who just raised their hand for the point slope form wants to always yell at me to have me do it that way, that's perfectly fine. So I'm going to choose one of these 2 points that makes me happier. I don't know. I would choose the 105, but whatever floats your boat. Doesn't matter which point you choose, you're going to come out to the same answer at the end of the day. If you use point slope form, it might look different because you don't do all the algebra to get it down to y equals mx plus b. But if you do the y equals mx plus b way, it doesn't matter which one you use, you'll get the same b value. So I'm going to use the 105. So I'm going to have 5 equals negative 1/2 times 100 plus b. Negative 1/2 times 100 is 50. Negative 50. Ooh. Add 50 to both sides. B is 55. Remember, you're not done, and you actually have to write the equation. So we have P equals negative 1/2 Q plus 55. Savvy? I want you to do the other way, so I want you to do Q as a function of P. I'll give you like a minute and a half. You want a piece of paper? That one. Wait, where's my paper? I have paper. If anyone needs paper, got paper. You need paper? Yeah, so there's a -50 on this side and then +5, but to get this over here, I have to add it.
Oh, okay, fine.
You're fine. You are good. Is there chats? No. So I'll give you another minute. See if anyone's frantically emailed me. I'm not trying to be rude. I'm answering a frantic email. So Q as a function of P. Whoop, that equal sign got real funky. So say I wanted to use the same 2 points, but that would now be 5, 100, and 10, 90. So I'm breezing through it because I assume you did it, but if there's something that you need to stop me at, and you're like, I got messed up on that step, stop me. Or maybe I'll just write it all out and then you'll tell me. But so that's a, what's that, -10/5, positive 10/5? -5, so -2. So say I use this point again, so 5 equals -2. No, what have I done? 100 equals -2 times 5 plus b. So 100 equals -10. Come on, pen. You can do it. I trust and believe. And plus b. Add 10 to both sides, get 110 equals b. So q equals -2p plus 110. I think that's right. Yeah. Questions, concerns? Doesn't seem like it. Okie doke. Last definition of this section is that formulas of the form y equals mx plus b are going to represent what is called the family of linear functions. And m and b are going to be called the parameters. So if you hear the word parameters in a question, it's just talking about the m and b values. All right, 1-2. So we're going to start 1-3 before your quiz. So I'll leave that up for another like 5 seconds. All right, and now I'm gonna pull up 1-3. So I might not actually have that up yet, but it's super easy to grab because it'll be over here and over here and right here. Goodness gracious. Boink. And then I've got to share my screen again. Boink. There we go. Average rates of change and relative change. We're not going to get through all of this today. So, well, I usually try to avoid this. I usually try to make sure that everything that's due on your homework is done by Friday, and maybe just the tiniest bit on Monday. So there's going to be a little bit on Monday that we still need to go over for your homework, which again is something that I try to avoid, but we got a little behind already. So things happen. So there is going to be a little bit of your homework that you can't quite do yet, but you'll be able to do the vast majority of it if you want to try to get most of it out of the way before Monday. And then Monday, you'll just have to get those last couple questions out of the way that day. So apologies. Again, I usually try to avoid that, but it is what it is. So if y is a function of x, so y equals f of x, then I always forget that, and it's going to start with blue, and I don't want that. I want black, please. Thank you. Then the average rate of change. I don't know why it keeps popping up. Oh, it doesn't do it on your screen. Anyway, average rate of change between x equals a and x equals b is the following. Y'all can't see my smirk underneath my mask. I always forget that. That probably looks pretty familiar. It looks exactly like slope, because it technically is. It's the reason it's a different name is because it's used in a different context. When we talk about the slope, we can only talk about slope when we're talking about a straight line. We can talk about an average rate of change between anything, even if we don't have a, so I should be careful. So it is talking about a slope of a line. It's just that the two things that we're talking about might not have been, originally on that line. It might be on a function, and I just want to find the average rates of change between the two values. But that's kind of why it is the same, but different, because it's a different context. So say we have the following table. It's going to give us the winning men's pole vault for the Olympics. I feel like we talked about that before, but now it's later dates. Anyway, so say we want to find the average rate of change between 1960 and 1964. So we're going to be looking at these two pieces right here. So if I want to find the average rate of change, I'm essentially you can literally think about average rate of change between these two as a slope between those 2 points. If you want to think about it that way, context is different, but if that helps you figure out how to do it, perfectly fine. So we're going to take these as our x's and these as our y's. So personal preference, I would put the 510 first. And then 1964 minus 1960. We've got that reduces to 40 over 4. Can someone tell me what the units of that are? Centimeters per year, whatever the units of the y are, divided by the units of the x. So centimeters per year. Cool. Well, then how about between 2008 and 2012? Well, now I just got to find the different data points. So the average rate of change between 2008 and 2012, well, I would take the 597 first. and write it correctly. Minus 596. So 2012 minus 2008. That's going to reduce to 1/4 centimeter per year. I'm going to give you 30 seconds for you to figure out what the average rate of change between 1960 and 2012 is. You should get, oh, some people got to type it in their calculator. They don't have the notes completely finished in front of their face. You should get 127 over 52. You didn't have a calculator on you as long as you had the setup correct. Correct. And that's how average rate of change goes. Correct. Questions? Okay. Let's do, I got 10 minutes. Okay. Let's do a couple more examples then. Use the following figure to estimate the average rate of change of the number of farms in the U.S. between 1950 and 1970. So that means I essentially need to figure out what those 2 points are. So 1950 is going to be approximately here. So that's going to be this point up here. And then 1970 is over here. So approximately there. So what are we looking at? We're looking at, and what? So that would be 5. So let's say, now, if this was something like on a quiz, I would expect varying answers. Like, I'm not expecting everyone to get the same exact estimate. But let's just say that's 5.3. I don't know. Good enough. So that's going to be 5.3, and this is in millions of farms, so million farms. And let's say 1970, I don't know, 2.8. So now my notes are not going to be right because I chose something differently than my notes. But now that I have the y values that I needed, I just go ahead and find the slope between those 2 points. So I have 5.3 minus 2.8 over, so 5.3 was in 1950, so 1950 minus 1970, which is going to be something. 5.3 minus 2.8 is 2.5. That's just going to be 20. Negative 20. If we care about what that is as an actual number, 2.5 divided by negative 20 is negative 0.125, which I believe is 1/8. It is. That's cool. Anyway. Now, if I wanted to say what the units are on this, that's going to be the units of y divided by the units of x. So it's going to be million farms. Oh, I ran out of space. Per year. So sorry, that kind of got smooshed. Okay. I would like to come back to example 3 on Tuesday and get the tiniest bit farther by jumping the tiniest bit. Is everyone good there? Jumping the tiniest bit. We'll talk about this and do example that one, and then we'll be done. Okay, cool. So jumping ahead a tiny little bit, we'll come back to that other example next time. the average rate of change does not imply that the change is constant over that time interval, or whatever interval. Consider if you're traveling from Columbia to Charleston, which is about 104 miles, and you do so in 2 hours. Then your average speed would be 52 miles an hour. That did not mean that you drove 52 miles an hour every single minute of that drive. It just means on average, you drove 52 miles per hour. So sometimes you drove less than that, sometimes you drove higher than that. So the average rate of change is not telling you exactly what's happening. It's telling you on average kind of what's going on between those 2 points. And that's essentially kind of what we've got going on here. So this is what I mean by it's a different context. That's not a straight line. So I can't talk about the slope of that function because it's not a straight line. But if I wanted to look at this point A and this point C, I could talk about the average rate of change between those 2 points. And what the average rate of change between those 2 points would be is the slope of the line between them. So the average, and I'm going to start abbreviating it rate of change because I'm lazy. So the average rate of change between A and C is the slope of the line between them. So that's what I was kind of getting at by saying the average rate of change is technically a slope, but it's used in a context when we also don't have a straight line, but there is a straight line involved. I think, does that make sense? It's the slope of the line between the 2 points, but it might be in context of things that wasn't originally a straight line. That's what I'm trying to say. Okay, and the last little bit is that I just want to note it's the same idea, but just slightly different wording. So I want to make sure that the wording doesn't freak you out if you see it on Wiley and think we didn't do it. We can also consider the same exact idea of the average rate of change, but in terms of the specific function of distance. And if it's the specific function of distance, if you're given a distance function, then the wordage is usually going to be average velocity instead of average rate of change, but it's the same thing. The average velocity is the average rate of change of distance. Okay, so average velocity means average rate of change of distance. So it's going to be some change in distance. Whoops, over a change in time. So if Wiley says to you find the average velocity, it's just find the average rate of change using the position function. So let's do one quick example of that, then we'll take our quiz, and then we'll be on our jolly way. So no question. Oh, cool. So consider the following table, which shows the height of a grapefruit above the ground 2 seconds after it was thrown. Find the change. Okay, that's actually the change and the average rate of change of the height of the grapefruit in the first 3 seconds. Give units and interpret your answer. The change literally just means when it's, so the first 3 seconds, maybe I should say this first. The first 3 seconds is going to be between t equals 0 and t equals 3, right? The first 3 seconds means when you start up into the 3rd second. If I just want the change in height in that time, I just literally want to know how high was it when it started, how high was it when it ended, what's the difference between those two numbers. So at 0 is a height of 6 feet, and at 3 it was a height of 162 feet. So the change, just generic change, is just going to be 162 minus 6, so 160 feet. Okay, so when it just says change, it just means literally how much, what is the difference between where it started and where it ended. So in words, yeah, no, I didn't arithmetic right. I thought it was 166 for some reason in my brain. This is 156. Is that right? Okay. Have I told y'all how bad my arithmetic is? I think I've told everybody else but you guys. My arithmetic's really bad. When I took number theory, there was something and she was like 3 times 2 And I was like, 5! And she was like, what? And it was number theory, so that was supposed to be the easy question, and I got it wrong. But anyway, so thanks for telling me that I'm dumb. So 156 feet. I was looking at my notes, and I was like, why do I say 156? So anyway, so what this would mean in words is essentially that the grapefruit goes up 156 feet in that 3 seconds. That's how far it traveled in that time. However you want to phrase that. It traveled 156 feet in 3 seconds, whatever floats your boat, however it gets point across. Whereas the average rate of change, we have to use those 2 points and essentially find the slope between them. So we've got 162 minus 6 over 3 minus 0, so 156 over 3. And my notes tell me that that is 52 feet per second. So the units of y over the units of x. And what this would mean in words, and again, we need to remember that this is not telling us exactly what happens, but what's telling us on average. So we would say in the first 3 seconds, the grapefruit travels on average. I'm saying this too wordy, but oh well, I started it. Travels on average with a velocity of 52 feet per second. Something that gets the point across that it's traveling about that fast on average during those first 3 seconds. And one more bit, and then we'll be done. As long as there are no questions on that. Okay. Find the average velocity of the grapefruit over the interval 4 to 6. Explain the sign of the answer. So here, average velocity, so just the average rate of change, again, between 4 and 6. So we've got 150 minus 30 over 4 minus 6. So 120 over negative 2. So negative 60 feet per second. And this is why it says explain the sign of the answer, because you might be wondering, well, how the heck can something travel negative velocity? Most of the time, unless it's specified differently in the problem, especially when we're talking about up versus down. Up is going to be positive velocity and down is going to be negative velocity. So this is kind of saying that on average, during the 4 to 6, it's traveling downwards during that time. On average, again. So the sign, negative sign, means on average was traveling downwards. Which kind of makes sense if you think about throwing something up in the air, because we live on Earth, eventually it has to come back down. So in the last 2 seconds, it's traveling back downwards. So that's why the velocity is considered negative in that case. Whew, savvy. Having back-to-back classes is fun because I just like talk for 4 hours on end and it's just obnoxious. All right, so now what I've got to do is I'm going to stop sharing my screen. I'm going to stop the recording.